Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. Today we'll be simply explaining affinity attributes and how to configure them in an MPLS-TE topology. I believe everyone should have the opportunity to learn telecom and networking without confusion. My goal is to simplify the tough stuff and make it accessible. So if you're finding this helpful, show your support by liking, subscribing, and hitting that bell. We've been going through a lot of different configuration features when it comes to an MPLS-TE topology and its capabilities. One of the things that we've touched a bit more on in the previous video is the way in which MPLS tunnels can be manipulated to take various paths throughout such a topology. We looked at two methods to do this, adjusting the TE metric as well as configuring an explicit path where specific routers or interfaces are either included or excluded from the path. But MPLS-TE has an even more powerful trick up its sleeve, and that's where the affinity attributes come in. Affinity attributes are attributes that you can define and use to cause tunnels to take particular paths. Unlike TE metrics and include and exclude options, the affinity attribute allows you to much more granularly define and configure the parameters that will affect this behavior. Now, what are affinity attributes? Well, these are essentially a set of flags that you as a network administrator define. There are no predefined flags, so you have to define them all yourself. These affinity attributes are a set of 32 bits where each bit acts as a flag with a value of 0 or 1, and each of those bits is given a specific meaning. Now, the affinity attribute set of flags is then written out as a hexadecimal value, and that's how it's configured within the devices themselves. So a set of flags that looks like this has the following hex value. So this hex value defines which flags are set to 1 and which flags are set to 0. Now I want to stress here, although affinity attributes seem to simply be a 32-bit number, like an IPv4 address, this is not the case. This is not how we interpret affinity attributes. They are strictly interpreted as flags, where each bit represents something that you've defined. You'll see what I mean shortly. Now, before we look more in detail at how we give meaning to each flag, let's first see how they are defined within the MPLS-TE topology. Each link in the network is assigned an affinity using the corresponding hex value. Specifically, this is applied on the interfaces of the PE and P routers. So each of these interfaces along this path are given a specific set of affinity attributes. Each one can have the same or different affinity attributes. Next, we can configure a set of affinity constraints for our tunnel. We do this on the head-end router where we configure all of our tunnel parameters. Now, based on the affinity flags configured on all the links within the topology, and based on the affinity constraints set on our tunnel, our constrained shortest path first algorithm will determine what path the tunnel will take. Now remember, CSPF is the algorithm that's used by the underlying IGP, that is, OSPF-TE in our case, to determine the path of the LSP. And it uses the configured affinity attributes as part of the SFP algorithm. Now, how is the path calculated and determined? The algorithm applies a bitwise AND operation between the affinity values of the links and the configured affinity constraints set on the TE tunnel. Now, since different links in the network can have different affinity values, CSPF evaluates each link independently during path computation. The bitwise AND operation is performed between each link's affinity value and the TE tunnel's affinity constraints to determine if the link is eligible to be used by the LSP or not. Based on this operation, the tunnel will either include or exclude that particular link. Now, there's one more thing I'd like to mention before we go into how we can define what each individual flag means. Now, as we said, there are 32 affinity attribute flags that we can choose from. However, we may not want to take all flags into account for our particular tunnel. Let's say that for our tunnel, we want to match only the 5 rightmost bits, but we want to ignore the values of the rest of the flags. On the tunnel configuration, we can configure what is called an affinity mask. The affinity mask essentially tells the CSPF algorithm in the head end router which flags to take into account when performing the calculation. So to confine the CSPF algorithm only to the last 5 bits of our affinity values, this is the mask that we would use. So only the bits specified by the number 1 in the mask matter to the CSPF algorithm. And both the affinity flags and the mask are written out in hex like so. Now you may find that the affinity mask is similar to the subnet mask for IPv4 addresses. And that is indeed the case. They perform very similar functions in 2 separate and very different areas. In any case, enough theory. Let's take a look at a real-world situation and define those flags. Now, before we look at our topology, let's define our flags first. We can use various characteristics, and it's really up to us. For example, we can say that the flags refer to various types of links. We can say that this flag, for example, refers to a fiber link, this flag refers to a satellite link, and this flag refers to a wireless microwave link. Or the flags can indicate which ISP is being used. Our network may be composed of some leased links as well from various ISPs. So this flag refers to ISP A, this flag to ISP B, and this flag to ISP C. Or we may specify geographical characteristics. For example, this flag may indicate that the link goes through country A. This flag indicates that it goes through country B, and this flag here may indicate that it goes through country C. Now the values you see here may all be zeros, but at this point we're not looking at the values, but we're looking at the position of the specific flags. So by defining what each flag position means, you can then go to all of your links in the topology and decide which flags will be set to 0 and which flags will be set to 1 based on the characteristics of that particular link. So let's say that this link here is indeed a fiber link. It belongs to ISP B and goes through country C. So if we set the appropriate affinity flags to 1, this is the set of affinity flags we get. So this link has been given these particular attributes. And those attributes are configured using the resulting 32-bit flags, and we convert them to hex. So for our resulting set of flags, we have a hex value of x91. Now, in order to apply this hex value, you can issue the following command. The MPLS traffic ENG attribute flags command is issued in interface configuration mode with the hex value of the configured flags. So now we've essentially marked each of these interfaces with the attributes we chose. Now we have the same attributes on both ends of this link, but that's not a requirement. You don't necessarily have to set the same value. You may set different values because this interface, for example, may be from ISP A, while this one is from ISP B. This link may actually represent a connection between these two ISPs. Or the values might be the same if, for example, it's a fiber link. So the same attribute value should exist on both sides of the link. But there is no constraint that tells you you must have it one way or another. You can assign whatever you like. It's all up to you. Now, if you choose to use affinity attributes, you should configure them on all of your interfaces in all of your topology. This is because if some interface is not configured with any affinity values, then the affinity value assigned to that particular link is treated as if it has all affinity flags set to 0. Now, this is important to keep in mind because this may potentially actively include or exclude an interface from being used by a tunnel that has some affinity constraints configured. Now that we've defined the characteristics of each link, we need to configure the affinity attributes we want to take into account on our tunnel. Let's say that we want to ensure that our tunnel avoids ISPA, uses ISPB and ISPC, avoids satellite links, uses fiber optic links and microwave links, and avoids countries B and C, but chooses to go through country A. If that were the case, then these are the resulting affinity constraints we need to configure on our tunnel. And since we only care about these 9 last bits, and the rest we don't care about, then this is the affinity mask that we would use. All of this here results in a hex value of 15C for our affinity constraints and an affinity mask of 1FF. Now we configure these values in the PE1 router tunnel configuration like so. And that's it. The result is that the CSPF algorithm will use these values along with the affinity values indicated on the various routers along the path to determine the path the LSP will take. Now this topology is quite small, so the large number of parameters we used will not really affect the path very much, since we really only have 2 options for the tunnel path, going either this way or that way. But you can see the huge number of values and options that you have available to more granularly adjust LSP paths, making the tunnels follow any path you like based on any characteristics of the links that you choose. For now, I hope you found this video useful, and if you have, please click that thumbs up button. If you have any questions or feedback, feel free to leave a comment below. I'm always happy to read them and to respond. And please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this has been helpful for you, and I'd like to thank you for watching.